Alright, what's up guys? In this video we're going to pick up some calculus here, and we're going to be talking about Simpson's rule, which is falls under the chapter numerical integration. So we're asked to use Simpson's rule to approximate the given integral where n is equal to 4. So you have this definite integral from 0 to 8, you got the square root of x dx. So this is Simpson's rule. So we did a video the other day on the trapezoidal rule, or the trapezoid rule, which again is just another rule to approximate a definite integral. So this is Simpson's rule. I probably took that up a little quickly. Okay. So much like we did for the trapezoidal rule, all we have to do here is just kind of use the formula. Okay. So we're given again here that n is equal to 4. We know that delta x, that's b minus a, all divided by n. So what is a and what is b? Those are just going to be our limits of integration. Okay. So a here, obviously, is 0. That's the lower limit of integration. B here is 8, which is the upper limit of integration. And n is obviously 4. So let's go ahead and do that. So we'll get delta x is equal to 8 minus 0, all divided by 4, which gives me 8 over 4, which you know is 2. So delta x is 2. Now x sub I are just going to be our endpoints. Okay. So in our case, if we go back to our formula, remember that x sub I here is going to be equal to a plus I delta x. We already know what a is. We already know what delta x is. So it's very easy to get x sub I, to get our endpoints. I guess I'll do it over here. So x sub I, so we'll get 0, 2, 4, 6, and 8. So x sub 0 here is 0, x sub 1 is 2, x sub 2 is 4, x sub 3 is 6, and x sub 4 will be 8. So f of x sub 0, well, that's just f of 0, which is 0. Then we need f of x sub 1, which is just going to be f of 2. And if we go back to, and when I'm talking about f of, I'm talking about our function here, which is square root of x. So that'd just be equal to square root of 2. We need f of x sub 2, which is just equal to f of 4, which would be the square root of 4, which you know is 2. And then we'll have f of x sub 3. Well, that's just f of 6, which is the square root of 6. And you can get these as decimal values if you want to, but I'm not going to. And then we got f of x sub 4, which is f of 8, which you give me the square root of 8, which we know if we do prime factorization, we can just write that as 2 times the square root of 2. So if we go to the formula, and all I'm doing here is just using the formula, kind of what we did for the trapezoidal rule, or the trapezoid rule. So from 0 to 8, we have the square root of x dx, and again that's approximately equal to delta x over 3. And then we got our formula, remember? In this case, it's just going to be f of x sub 0, hopefully I can fit it in here, plus 4, f of x sub 1, plus 2, f of x sub 2, plus 4, f of x sub 3, plus f of x sub 4. All I'm doing here is following the formula. Alright, so say we'll get 2 over 3. Alright, so And that's the purpose of getting all of this over here, f of x sub 0, f of x sub 1, x sub 0, is because we have to we now need to plug that information in. All right, so all we're doing is using the formula. So this would be 0 plus 4 times the square root of 2. Looks like we'll have plus 2 times 2 plus 4 times the square root of 6. And this would be plus 2 times the square root of 2. So you get a calculator. Get 2 over 3. Multiply that by 0 plus 4 times, oops, not alpha, times the square root of 2. And then it's going to be plus 2 times 2 plus 4 times the square root of 6 plus 2 square root of 2. It looks like we're going to get 14.85. It's not approximate. It's actually going to be equal to 14.85. Okay, so for the final answer for this, all right, so from A to B, f of x dx, we say that's approximately s sub n, which is 14.85, which is what you get when you plug it in a calculator. Now you do got to make sure that you plug it in there correctly and plug it in there slowly, otherwise you'll probably get the wrong answer. So that's how you do it. All I did here was just use the formula. All right, so I hope that made sense. If you guys got any question about how I got my answer, let me know. We will go over it. So I'll see you guys next time.